here is the algorithm. The algorithm have a little bit of detail. I'm going to talk about it a little later. You start from k equal 1. That means in each basket only have one item. And it depends on how many items, the items you have in all the transactions. Then your first is just a D. So generate the frequent item set of length 1. That means among all the D items, you only go those past the, let's say 40%. Past 40% that you keep. Anything below 40%, throw it away. Yeah. The second, from what you have the one item element, you're going to build a two item element. From 2, you're going to build a 3. From 3, you'll build a 4. From the bottom up. So each time when you build up, you're going to throw away those who infrequent sets, and then keep only the frequent set. So in the end, each time when you get the set, how do you find this frequency? You need to go to the basket, the transaction list. Each time look at each list, because each transaction, now here's the real trick. Each transaction could contain a few or many of your subsets, your basket. Are you with me? If your transaction, one transaction have 15 items, and your subset maybe 3 elements, 3 item subsets. This 15 could compare, choose 3 from 15, that's a lot. That one transaction need to look for the combination of choose 3 from 15, that's 15 times 14 times 2, 13 divided by 3 times 2 times 1. That's how many? Hundreds. Just for look at one transaction, you need to look at hundreds. Are you with me? Okay. That's the demo. The detail. So when you do the merge, there's 2 different ways to merge from the k item to the k plus 1 item, or from 2 items to 3 items, 3 items to 4 items. You either use the k minus 1 item to k, or k minus 1, k minus 1. That's up to you. And from here, you're going to get the k plus 1. That's just merging. So brute force. How do you brute force this? If I have 6 items, 6 items. 6 items, I want to see how many 3 item basket I have. 3 items, you need to choose 3 out of 6. That will be 6 times 5 times 4, divided by 3 times 2 times 1. Then take the 6, you have 20, right? You have 20. Among these 20, then you're going to look at all the transactions. You might find only one past this 3 threshold. That's called brute force. But I said this does not work well, because the 3b minus, that's huge number. So here you need to look at 20, only 6 elements. And then you need to compare to each of the 5 transactions. Well, that's why computational science is so important. One method is this. We know only 4 passed the 3 threshold, only 4 passed the 2 threshold, and we merge these 2, we only get this 4 possible subset, which are candidate, and then we go to the transaction, we count only 1 passed the 3. That's how we do a little smarter, instead of brute force. Instead of brute force, we do that a little smarter. You see, k minus 1, k minus 1 means in order to get the 3 sets, I start from the two sets. Both are the 2 item sets. Go to the 3 item sets. Similar, but just different. The next question is, how are you going to count? And here, so far, what I enumerated is simply all the possible candidates of the subsets. And you know this total subset is 2 to d minus 1, except the empty one. So far, we only just get the subsets. not even think about how I'm going to count with all the transactions. Which one covered how many times? That's what I'm concerned, right? Okay. So what is this? From the candidate, the item contain infrequent lengths of the K subset. That's the devil. You need to look at the detail. Because you have to count your subset already huge compared to the transaction. Each basket, you can make many sets, and how these two count each other. Use that one to see if that set have a 1 time, 2 times, like you check, like the vote, right? It's a huge check. This is what you have to count. Let's say in this transaction, I have 1, 2, 3, 5, 6. You don't have the 4. Those are the egg, something, each one is an element. And this 5-element basket, total I have this 10 possible 3 sets. 10 possible 3 sets. And then on the other hand, you got all these 15 3 sets, or maybe less, depends. Then you're going to count, if this happened once, you check the 1. If it happened again in another transaction, you check 1. That's how you have to do it. Hash table, if you're in computer science, you know what means hash table. It means depend on if it's 1 or 2 or 3, depends. You modulus, you divide the first branch, so always have a remainder of 1, second have a remainder of 2, the third have a remainder of 0, right? You modulus 3, divide 3, that's how I assign your project. You remember which one you use your social security. That's the same idea. Hash. The good thing is the hash tables, you always can have the head use the index to find your element quicker. That's how you do the hashing. It's a very practical way to do things. Organize the element how to find. Well, you build this 10 element in this hash table. If originally you have a few, then you get more, and later on, because you only need to build once, and you always have a way to trace it, and then you can easily count. You don't rebuild it again and again for the 3 elements. I'm not going to go through all the details because we really don't have time. Once you find all this called frequent set, you only finish half of the work. You still only finish half of the work. Now, what we are looking for is not the basket itself. It's about if you have something, you're going to imply you're going to get something else, right? The next step, when you get all this frequent happen, you're going to split the basket into, if you purchase the 2 dagger and bread, then you're going to purchase the beer, and then we need at this stage, I only found that about the beer, bread, and the dagger, they're frequent enough, appeared in the same basket, right? But sometimes you do have only the dagger imply the beer. It's also in other baskets. Can you see? So you are only halfway so far. The other halfway, we are going to, based on these frequent sets, to look for the set, the implication for this association rule past the, what keyword? So far, we only use the one keyword, the support, right?
Confidence.
Confidence, yes. Past the confidence, minimum confidence. Then you're going to get the association. Then you can claim you found something, right? But if you find something, those something is valuable. So the next stage, we're going to get this set called the X. I'm going to divide this X 2 parts. One is the precondition on the left. Another one is the consequence, the follow-up on the right. And then we're going to look and see if those always pass the minimum confidence. Now, again, you have a simple rule called a priori algorithm. If X always implies the Y minus X, remember it need to be mutually exclusive. That's Y minus X. if X always imply this, and the X prime is a subset, and then of course this subset always implies this same thing, right? If the superset also implies the subset always pass the same frequency, right? Because remember, the subset always more frequent than the superset, right? So this is guaranteed. So now to use that, if I know this is a low confidence, you need a reverse monotonic. That means if this one does not pass the confidence rule, and then none of the superset, this one is going to pass this, let me see, low confidence rule. Yes. If this is low confidence, and then this superset in here is low confidence, you wouldn't pass it. On the other hand, it's also true. If the big set passes the confidence, then this is also going to pass the confidence. You only work one way when you think about it. Yes, if it's low confidence, this you need to cut it off, because there's no possibility for you to pass that and imply this. You see, the more you increase on the right hand, the more unlike, are you with me? It will happen, right? And this tree, basically, if you have this transactions, instead of build the whole tree node as the items, actually, you build another tree. You build the branches. And those branches, you look at the path, that will be in one of the set. That will be computationally efficient. And then you can repeat here, B here, and then you build a path because the index, you can build this, okay, now I have 2. And you can build more. When you look at more, each time, basically, when you scan through the transaction, you just start always from the transaction. Instead of, in the previous method, we look at all possible subsets, right? We don't do that. We just start from the transaction, build these trees. It's not you look at it. And then you build a forest, by the way. That you call it forest. And then, when each time you read, let's say you get the head A, B, C, D, and that's how you index and try to find the path. And then you look at this, one item A, B, A is there, and the B is there, and then you can go to the path here. That's A, B, and then you look at the same thing. Could happen again, D, and then you're going to count it that way. So that's another way, a lot of research. Another one will be storage efficient. But each time you're going to traverse the tree, look at the path. That will be at least save you the stage to enumerate all subsets. And then you just look at the inside to see which path you travel it, count to see which path passed this minimum support, right? And then you get this in. So sometimes you set this minimum support too low, you end up too many things come together. Really, that's not telling you anything. If you set it too high, just too little. You don't find anything, right? So set the right range, that's your expertise. And define the problem is harder than you solve the problem. So those same data mining, again, let me say, define the problem is harder than you solve the problem. You really need to define it meaningful. If your problem not defined and meaningful, you can do your computation forever. That would tell you something. So we need to look at this, understand the algorithm, understand the limit, and then set the right low limit and the high limit. And now there's one strategy is to simply make a difference between the maximum support to the minimum support in a range for a set which depends on the product with different threshold. That's practical, you can do that. And you can do multi-round if you want. You can split into different caskets, different transaction list if you want.